Okay, in problem number 8, we have a ladder that's 5 meters long, rests along a wall 4 meters above the floor. It says the ladder has a mass of 25 kilograms and the center of mass is at the center of the ladder. It wants to know what is the minimum amount of friction between the floor and the ladder needed to keep the bottom from sliding out. Okay, so it already has the free body diagram drawn here for us. So let's write some equations. One equation would be that the force from the ground, which is normal force, would be equal to the weight force, mg. And the other one would be the force from the wall would be equal to the force from the friction, static friction. We know what the weight is, so that means we know the normal, but we don't know the force from the wall. And so that means we don't know what the force from the friction is either. So now we have to consider torque. So let's put the pivot point down here to eliminate two torques, the torque from the support force and from the friction. And we can write a torque equation, and that would be the torque from the wall has to be equal to the torque from the weight. And the torque from the wall would be the force from the wall times the distance, which is 5 meters, times the sine of the angle. Now the angle we're talking about here is this angle here. That angle there happens to be the same as this angle. And in the problem it's told to you that the length of the ladder is 5 meters and the height here is 4 meters. Which means this height over here is 3 meters, by the way. So if this angle is the same as this angle, that means the sine of this angle would be equal to 4 over 5. So the sine of the angle, instead of figuring out what the angle is just simply going to be 4 divided by 5. That equals the weight, which is 250 newtons, times the distance, which is 2.5 meters, times the sine of this angle. So this angle here. That angle there, by the way, happens to be the same as this angle. So the sine of this angle would be 3 over 5. So 3 divided by 5. So that means I can figure out what the force from the wall is. That's going to be, doing the calculation, 93.75 newtons, which by the way is the same as the force from the friction, which is what we were trying to find in the first place.